Okay guys, this is our mid-unit 3 review. So we're going to practice the we do's in this video, and then you guys can practice on your own the I do problems. All right, here we go. We have a graph and we're asked for some attributes. So the first thing that we're asked for are zeros, or a zero. And it's important to know that a 0 and an x-intercept are basically asking for the same information. They want to know, where does my graph cross the x-axis? So if I look right here, I can see that my graph crosses the x-axis right here at the number 2. So if you're asked for the 0, we generally write it as x equals 2. Or for an x-intercept, you can write it as a point, 2, 0. Remember, your x value always comes first, and then the y value that goes with it. Now your y-intercept is asking for where your graph crosses the y-axis. So I have my y-axis right here, and I can see that my graph crosses the y-axis at positive 3. So as a y-intercept, an ordered pair would be 0, 3. It's going to be x first and then y. Now we also want to know about slope. Slope is the same thing as saying rise over run. So it doesn't matter which point you start at, but I'm going to use the y-intercept to begin, and I would go down 1, 2, 3, and because it's down, it's going to be a negative 3, and then I'm going to count to the right 2 steps, and because it's to the right, that would be a positive 2. So I know my slope for this problem is negative 3 over positive 2. And then the last piece of information, we just ask you guys to plot the point 4, 3. Remember, x comes first and then y. So if we start at the origin, we move to the right 4 and then down 3, and this is where we land. Okay, so that's just some attributes of linear functions. Now what happens when we have a word problem? It says Devin owes his parents money. He does weekly chores to earn money to pay them back. The graph models the relationship between Devin's debt and the number of weeks he has completed his chores. What does the x-intercept mean? Well, the first thing that you want to pay attention to is the fact that our x-axis is labeled number of weeks and our y-axis is labeled dollars. So our graph crosses the x-axis at the point here, 8, 0. Oops, I wanted to use blue. Here we go. 8, 0. So I know the 8 represents the number of weeks, and I know that the y value represents dollars. So what do we think that means? Well, after 8 weeks of doing chores, he has $0. Now, up until that point, he was in the negative. He had negative amounts of money, so he owed his parents all of this money. But on the 8th week, he no longer owed them any money. So it was the number of weeks it took. So number of weeks Devin took to pay his parents back. And those number of weeks, it was the number 8, so I guess I should squeeze that in right there. The number of weeks, 8, that Devin took to pay his parents back. Now, what does the y-intercept mean? Well, that is where my graph crosses the y-axis. And I can see that that happens right here at negative 60. So again, as an ordered pair, that number is 0, negative 60, where the 0 represents the number of weeks, and then the y value is the amount of money that Devin owes. Well, at week 0, he owes them negative $60. So the y-intercept in this case is the amount of money Devin owes. The amount of money that Devin owes, which is $60. And by owing money, that implies it's a negative 60. Ignore that. Okay, what does the rate of change represent? And remember that rate of change is the same thing as saying slope. But because it's a word problem, it is important that we pay attention to our labels. Our y-axis, again, is labeled dollars. So it's dollars. And our x-axis is labeled number of weeks. So I need to label this number of weeks. Now let's check our rise over our run, or the change in y over the change in x. So I have 2 points on my grid here already well clearly marked, okay? They're integer points. I don't have to worry about decimals with my y-intercept and my x-intercept. So let's count our rise. It's important to recognize, though, that every single square is 10 units, okay? So we're going to count by tens. 10, 20, 30, 40, 50, 60. We rise 60. So I am going to put the number 60 in my numerator for $60. And then my run, it's important to recognize that my x-axis is counting by ones. So we can just count by ones. 1, 2, 3, 4, 5, 6, 7, 8. Whoops. So $60 in 8 weeks. That's the rate at which Devin is paying back his parents. So 60 divided by 8 gives us 7.5. So right here we would just say Devin pays back $7.50 per 1 week. So per week, $7.50 per week. Now we need to write the equation of a line. And remember, the equation of a line is just y equals mx plus b, where m is our slope and b is our y-intercept. So slope goes there and the y-intercept goes there. So we have y equals 7.50 times our x value, and then our b value is where Devin starts out, and he starts out with negative $60, so minus 60. And that is the equation that represents this situation. Okay, now let's go to another problem. It says a heat wave in San Antonio, Texas, and the graph shows the outside temperature with respect to the time passed in hours. Find the rate of change, which again is just our slope, or our rise over our run. And because it's a word problem, again, we want to pay attention to the fact that we have our x-axis labeled in hours, and we're counting by units of 1. And our y-axis is labeled in degrees Fahrenheit, and each square is worth 12 units. 0 to 12 is 12 units. So all we need to do is find 2 integer points, okay? They cross our grid lines in the corners. They're really good points right here. So I have 84, 0, 0, 84, and then this point right here, 5, 96, okay? So all I need to do, if you would like, you can label these points. My x value is 0, my y value is 84. The second point is located at 5, 96. You can use your slope formula, but I'm just going to count my rise over my run. To go from 84 to 96 is 1 square, and remember we said that 1 square is worth 12 degrees. So I know I'm rising, or I'm increasing 12, and then my x-axis is counting by units of 1, so let's count that. We have 1, 2, 3, 4, 5. So again, going to the right is positive. So I know that my rise over my run is 12 over 5. Okay, now the rise is in degrees Fahrenheit, and the run is in hours. Now you can't simplify that fraction, but you can turn it into a decimal if you would like to. 12 divided by 5 is 2.4. So our slope is equal to 2.4 degrees Fahrenheit for every 1 hour. So the temperature is increasing by 2.4 degrees Fahrenheit per hour. Okay, here we have a rate of change where we have laps and our time in seconds. We don't really know anything else about this word problem, but we do know laps and we know seconds, okay? So this is similar to a graph, except that I can't just count on a grid or a number line, so I'm gonna go ahead and use the slope formula. And the slope formula is always on your star chart if you need it. It's y2 minus y1 over x2 minus x1. So I can pick any 2 points that I want in this table. I'll just go with this first point and the third point so that I don't have to work with any decimals. And I want to label them, okay? If I label the number 2 my x1 value, then the number 71 has to be y1. And for my second point, I'll label the number 8 as x2, and the 284 that goes with it is my y2. So we can just plug those values into our slope formula. So m equals y2 minus y1. Our y2 value is 284, and then we are going to subtract the y1, which is 71, over our x values. We start with x2, which is the number 8, minus x1, which is the number 2. Now, if you guys use a graphing calculator like the TI Inspire, you can hit Control Divide and type it in just like this, or you can use Desmos. Either way that you want to simplify this is fine with me. So when we type this into our calculator, we end up getting a fraction of 71 over 2. Which doesn't make a whole lot of sense when we're doing a word problem, so I'm going to convert that to a decimal, and I get 35.5. But like I said, because this is a word problem, we need to put the units of measure in it. So it's the change in y over the change in x. Remember, your y value was time in seconds, so I'm going to say 35.5 seconds per every 1 lap. Whoops. 1 lap, okay? So this fraction, this number reduces down to 35.5, and we want to use our labels, seconds over laps. So 35.5 seconds, the fraction bar means per lap. All right, let's look at this one. Write a linear equation, y equals mx plus b. It's just important to remember that the m value is always your slope. It's always attached to the x. And your b value is your y-intercept. So knowing that, it's pretty easy to solve this problem. If you look right here, I can see that my graph crosses my y-axis at -6. And then I look for my slope. And again, we just want to choose 2 points that cross my grid lines in the corners so that I have whole number points. It's easier for me to count. Now, if I look at my y-axis, I see that each square is worth 3. So each of these steps up is actually worth 3. So make sure you're counting correctly, okay? So I'm going to start at my -6 for my y-intercept, and I'm going to go up 3, 6, 9 steps. So that's a +9. And then my x-axis, if you look right there, those values are counting by 2s. Every square is worth 2 units. So my run is 2, 4. So this is a +4. So I know my slope is a +9 over a +4. So I can just rewrite this as y equals 9 over 4x minus 6. And there's my answer. All right, one more problem. We have a table of values, and it says write a linear equation in y equals mx plus b. All right, so I'm looking at this table, and it doesn't have any labels other than x and y. So if I'm looking for my y-intercept, it's important for me to remember that as an ordered pair, my y-intercept always has an x value of 0. Whatever the y is, the x value has to be 0. And I can see that that point exists right here. This is my y-intercept. Okay? Now, you can pick any 2 points you want on the table in order to determine our slope. And then we'll just use our slope formula. Remember, it's just y2 minus y1 over x2 minus x1. Okay, you can pick any 2 points that you want. If you choose this as x1, y1, You can choose the y-intercept point as x2, y2. And again, it doesn't matter which values you choose. Okay, so y2, with the way we have this labeled, is 12 minus our y1, which is 0, over our x2 value was a 0, minus our x1 value was a -4. So I'm going to put that in parentheses because I have this double negative. Now you can type that into the calculator or Desmos exactly like it is, but I know that subtracting a negative is just like saying plus. I'm getting rid of negative symbols. So my numerator is 12 and my denominator is 4, which just reduces to the number 3. So this equation is just y equals m is my slope, which is 3, so 3 times x, and then my b value is a positive 12, so plus 12. And don't forget that anytime you are taking a test and you want to check your work, if you have a table of values, you can always use the regression feature either in your calculator or on Desmos to check yourself. Again, the same thing happens right here. You can use the regression feature. Just remember that you're looking for the letter M. M is always going to represent our slope, either in Desmos or in our calculator. And